research behind them. They're being eaten every day right now. You know, there's everything from mushrooms that don't go brown to apples that don't get brown. There are this Impossible Burger, which is a synthetic biology version of hemoglobin that is supposed to taste like meat. I've never tasted one, but I know Michael Hansen is anxious to tell you that story, which is shocking. Just at the lack of thought and regulation that surrounds it. And that's just the consumer aspect. When you start to look at some of these technologies from the worldwide farming aspect, which really is about what this conference is about, I think it's equally shocking. You know, I think that humanity almost has this choice of do we go with this moneyed vision of agriculture that's we virtually, you know, they're looking at virtually eliminating farmers. You know, farmers are kind of too messy. When there's a hurricane in Haiti and the vetiver crop is destroyed, that's a problem for these companies. They would rather be producing the vetiver in a vat in somewhere in California. And the real problem with that whole model is that they got to feed the bacteria that are spitting out this chemical something, and what that looks like generally is intensively raised sugar cane. It's monocrops that are feeding this machine. So it's an absolutely insane model that they're trying to shove down our throats. And you know, I guarantee you there's probably even today there's conferences around the Bay Area where you go in them and it's like this is the future. You know, this is where all the money is going. We in the Bay Area are the absolute epicenter of this movement, and they really have this vision of revolutionizing agriculture on us, and it's quite shocking. So I always feel a little bit like I'm, you know, giving a lot of bad news to people, and sorry, I feel like it's important for us to understand this is what we're up against, and I don't think any of us really have that much solutions here. But hopefully with all the other solutions we're hearing about climate change, it will fit into that. Yeah, one of the things I wanted to just mention too is like in preparation for this talk, I just went online and looked at some of their websites, and I was even shocked. Like, you know, this one company, Amyris, which they're not, my understanding is that they're not really making products. What they're doing is they're licensing the technology to companies. So, you know, if you wanted a bacteria that would spit out some obscure chemical, you could go to Amyris and basically say, this is what I want, and they would make you, through synthetic biology, a bacteria that you could then buy from them and cultivate for yourselves. And that's the world that we live in. One of the things that I found out on their website is that they're actually, you know, proud of the fact that they're working hand in hand with DARPA, which is the Defense Department's research arm. So this is our military that is researching these things too. So if you want to get scared. So with that, I think I'll introduce our first speaker. You know, he was one of those people that, you know, I was involved in the ban in Marin County for GMOs, you know, 12 years ago, and I remember Ignacio was one of the people out there that we called on to come and help, and he was so generous with his time, and as always. Ignacio Cappella is a microbial ecologist and mycologist at the UC Berkeley, and he's perhaps best known for the fact that in 2001, he and his team produced a paper that documented about the transgenic contamination that was happening in Mexico. And this is the part of Mexico where corn originated. So the fact that there was actually GMOs being discovered in those crops was quite shocking, and it created quite a stir in the world. And because he had really the courage to question the GMO machine or economic machine, and specifically when it had to do with UC Berkeley and them being, you know, all this money being thrown at them, and he spoke up about that compromising the integrity of the university, and at that point they actually tried to take his tenure away, and he had to go to court to fight that. Fortunately, the courts worked, and he's still at UC Berkeley teaching. So I kind of wanted to just open it up and, maybe start out asking Ignacio just to, maybe give us a little bit of the history of I think the synthetic biology thing really began right here. And I thought maybe he could share with us a little bit of that and the farming implications. Thank you.
Great to be here. Thank you. I'm sorry I cannot see your faces. That is a little bit troubling, but I'm still here. I'm old. I didn't used to be, but now I am, and I'm. It's a happy thing to be, in many ways. One of the benefits of age is that you get to tell stories. You get to tell stories based on what happened, rather than be in that childlike stage where you are just imagining what the world might be, could be, will be, and so on, with all kinds of emotions that are interesting too. But the emotion of having a historical background to draw from is one that we really should promote. And so I come to you from that perspective because whether I want it or not, I am someone who from about age 14 has been really dedicated, out of passion really, to trying to understand the world of the living. And whether I want it or not, that quest in my life really matched the development of this thing that we are today talking about as biotechnology, with all kinds of different names. So I am a little bit of an ethnographic item for you here, and I'm also happy for that because I feel like I have the history of biotechnology in my own personal and professional history, and that's where I'm coming from. We are supposed to be talking today about emergent technologies. We are apparently supposed to be talking about synthetic biology. Some people are very, very concerned and excited in both positive and negative ways about something that people are calling gene editing or genetic editing. In this genetic editing, we're echoing something that happened in 2000, just a little bit of history, how Bill Clinton and what was his name, Prime Minister of the UK? Tony Blair. Together, Tony Blair through satellite and Bill Clinton holding hands with Craig Venter and the public representative of the Human Genome Project, and they announced that we had finally cracked the code of God, the code of nature, and the book of God, I think, is the formulation, that we now can read the book, and now it's time to start editing. This is Craig Venter's idea that we left the past behind and now we can join. There's a lot of religious people who feel that this is a very religious quest, that what we're doing is we're joining the creation effort, that we're this special being on the planet that is helping God with the last stages of creation and so on. Many things have come up from this quest that is about 40 years in the making, in the actual physical making. First genetic engineering organism, 1972. First release, the late 70s, early 80s, out of Berkeley, Steve Lindau, the ice minus bacterium, here in California, here in the Bay Area, here in the heart of the Bay Area at Berkeley. So we have a long history. Many things have come out of it, most of it hot air. I think one of the best things, from their point of view, one of the best things that they finally came up with is a term that is not synthetic biology, that is not genetic editing. It is called new gen technologies or new gen biotechnology. This is a really smart and useful term. It's a really great invention if we want to talk about inventions. It's an invention that will allow them to hide behind the future the way they've been doing for 40 years without having to prove any product. Next generation will allow them to say, well, we got it wrong the last time, which is what the so-called gene editors are saying now. We got it wrong last time. It's true that genetically engineered crops really didn't work the way we wanted. It's true that we didn't produce all the promises that we made in the 70s, 80s, and 90s have never come to fruition. We've been talking about them, but we haven't produced them. It's really true, but that's because it's in the past. Now we have a new generation of so-called technologies that are going to make that possible. So I think the biggest discovery, the biggest invention here is this term. It is a semantic intervention rather than a biological one. Why is a semantic intervention necessary? You know, cell phone people who produce the nuclear bomb, also out of Berkeley, they don't need to come up with this kind of idea, this kind of pushing things forward into the future unnecessarily, because cell phones work. The nuclear bomb worked, whether you like it or not. But genetic engineering did not work. It did not produce what they were promising would produce. The actual products didn't happen. I don't have time to go through the numbers. What I'm trying to just put out there for you is little pointers to grab from in history, to start, I think, turning around the way things are presented by even very good newspapers like the New York Times, for example, and trying to reconceptualize what it is that we're really talking about. So it is, it has been a long time, and they have not really produced what they promised they would. 2 products, 4 crops, 5 countries account for 98% of the acreage of GMO crops, and that continues to be the one place where they have had some success for many different reasons, not least political, not least the support of the US federal government that we all know about. Example of Amiris, another company that Mark brought up. They continue to be alive for some kind of miraculous reason. This is a company that came up out of Berkeley. We subsidized it tremendously to the point that we put in a building up for them to meet with BP at the time when BP and Chevron were fooled into, I believe, believing that now the problem of producing fuels was going to be resolved through so-called synthetic biology. I'm talking about 10, 15 years ago. And now Amiris, I hear from Mark, has no products. They sell a no-product. They got the US Navy to say they would buy all the biofuels they could produce. They had plants in Brazil, big accidents there, big problems there, but they never really produced anything that was competitive. They moved, then after that, they moved into the perfume industry. They figured out that it was easier to sell their so-called products by the milligram rather than by the ton, which is really a no-brainer. But in the end, the quest for biofuels that was just so hyped, not too long ago, 10 years ago, even some people today continue to believe that we're going to produce biofuels from algae and from all kinds of different organisms that are genetically engineered, genetically edited, and so on, hasn't come to fruition and will never come to fruition. The reason why, I'm just very worried about time, so I'm sorry if I'm being telegraphic here. The reason why is because the great, big, and really very expensive edifice of genetic engineering, which includes CRISPR and talents and zinc fingers and all these other things that you keep hearing as a new generation of biotechnologies. The great edifice of biotechnology is founded on really muddy foundations, foundations of sand that really do not exist. The foundation of genetic engineering, including CRISPR, including talents, including all the synthetic biologists that you've heard about, the foundation of that biotechnology is something called the Central Dogma. The Central Dogma, very briefly put, tells us and teaches our children to believe in the idea that you can pull out a chemical out of a living form, a reproducing organism, and pull that piece of DNA, stick it into another life form, and get a so-called trait, a behavior, a part, that will make that other organism, the recipient, behave like the first organism. I always like to use my preferred goal for biotechnology, which is to have flying pigs. I would like to have flying pigs. If you could find the gene, so-called, the piece of DNA that so-called codes for wings in the swan, and move it into the pig, then you could have flying pigs. This is the idea behind the Central Dogma of molecular biology, the Central Dogma of biology, the Central Dogma it is called. And we continue to teach it to our little children. In all the science museums, you will see the Central Dogma centrally and dogmatically presented to all of us. We teach it also to our genetics students at Cal, at Stanford, at Harvard, and I've been checking on courses on genetics that are online, and we still today, the first few weeks of genetics are involved in an indoctrination into the Central Dogma. That includes not questioning it. So if you believe in the Central Dogma, you believe in the foundation of biotechnology, and then you can start getting into all these discussions, all these confusions, build up, and you can help build that castle. Sometimes by criticizing and attacking it on its own terms, and saying, oh my gosh, I really should be concerned because you're telling me you're going to produce flying pigs, and I would not like to receive pig manure on my head. By doing that, I'm forgetting that I'm just, wow, is that appropriate? BSing you with bull. Oh. I'm finishing now. You forget to question that what I'm using to scare you or to give me money, for example, as venture capital money, is supported by a sandy, muddy, faulty foundation, the Central Dogma. So if there is one pointer that I want to leave you with is question the Central Dogma. Secondly, remember, do not buy the next-gen idea. We've given them enough time, enough money. It's time to look at different ways of dealing with the world. Thank you.
Thanks, Ignacio. So, you know, our next speaker is Stacy Malkan, and I think she'll kind of explain to us, I hope, why we keep buying this BS, and or the American people do, not you guys. So Stacy is the author of an award-winning book, Not Just a Pretty Face, The Ugly Side of the Beauty Industry, which is, you know, so she's been involved in a campaign for safe cosmetics, a coalition of nonprofit and health environmental groups that's helped to shift the beauty industry away from harmful chemicals. Stacy has been named one of the 5 visionary leading the charge to better health by Experience Life magazine, and one of 7 powerful women in the natural beauty industry by New Hope 360. She's appeared on numerous movies, including The Human Experiment, produced by Sean Penn. I first got to know Stacy in 2012 when she was the media director for Prop 37, the labeling campaign that, you know, really, we only lost by 1.5 points there. So, you know, not only did it come quite close, but it also started a real revolution across the country of awareness about GMO issues. So now Stacy runs the U.S. Right to Know campaign, which has been doing a lot of the really, hard-hitting investigation into what has been happening to grab our media away from us and tell all these lies about it. So with that, she'll tell you her story. Thank you.
Thank you, Mark, and everyone. I'm so thrilled to share the panel with both of you. Brilliant, all of you brilliant people, and to be here with so many. I've heard today just so many inspiring stories of hope and heart, and I feel so much better than I did yesterday. I do a lot of work kind of isolated and looking at the ugly side of the food industry, I'll say. I wanted to start out actually with talking about an article that was recently in the Los Angeles Times by Mike Hiltzik. He's a columnist, not very much a friend to GMO labeling campaigns, but he wrote a great piece interviewing Jennifer Doudna, and she is the inventor of Crispr in Berkeley. And the headline of this piece is "Crispr Pioneer Jennifer Doudna Struggles with the Ethical Implications of What She Has Wrought." And she has a new book out. It's called A Crack in Creation, Gene Editing and the Unthinkable Power to Control Evolution. And it opens with the stark observation that the revolution in gene editing launched by CRISPR offers both the greatest promise and arguably the greatest peril for the future of humanity. And then he explains that what sets CRISPR, and that's what's often referred to as gene editing or sometimes sold as super precise. I'm sure Michael will talk a little bit more about how that is not true, but it's basically snipping and changing a gene, allowing genetic engineering to happen much faster. And another difference is that is the ease with which it allows users to alter DNA not only in the somatic cells but the germ cells, which can be passed on to future generations. So changes to those cells can become part of evolutionary legacies. So obviously those changes need to be very carefully considered, for once scientists embark down that road, there may be no turning back. So that's in the story, and then he explains that this knowledge has been keeping Jennifer up at night, and she tells the story in the book of a dream she had in 2014 when CRISPR first became widely distributed. She was jolted by a dream in which she was brought to see Adolf Hitler, who asked for a description of the uses and implications of this amazing technology. She lay awake pondering how CRISPR's truly incredible power could be devastating if it fell into the wrong hands. And so she talks about the technology with great hope, but also that humbleness of knowing what happens if it falls into the wrong hands. And so we need to be considering, when we think about these new technologies, the new faster, better, supposedly easier ways to change genetics, what context is it happening within? So I wanted to talk about context today and think about genetic engineering always in context. And so changing a gene, of course, is not just a simple one change. It's happening within an ecosystem, so any changes to a gene can and does often have off-target effects. It's also happening, genetic engineering, while it could be used for good or bad, it's happening in a context of politics and a context of economics in a system that is itself toxic and unhealthy. So my own personal context in this is that I'm a mom and a consumer. I buy most of the food for my family. I want to know what's in the food I'm buying. I want to know how it's produced. And that was what Proposition 37, the GMO labeling initiative in California, was about. And thank you to all of us in this room who worked on it, all of you, many, many, many passionate activists were in that fight. And what a fight it was. I was the media director, so I really saw firsthand, what Monsanto and the other chemical companies, the junk food companies, brought to that fight. And it really could only be described as a full court press of deception, denial, ugliness, and dirty tricks. It all unrolled, for those of you here, pretty much over a very difficult 37 days, starting October 1st up till the election where they were spending basically $1 million a day carpet bombing California with messages of deception. And from there, it did work, unfortunately. Although important to remember that we did, as Mark said, we almost won it. We came so close. We did win on election day, and we did come out. I think this is a really important lesson from Prop 37 with a positive, hopeful, loving message at the end. The ad that the campaign ran was called "Food is Love," and it was about that idea of women and moms and all of us, parents and families, showing love through the food that we eat and share with each other. And that's something that motivates people and people believe in, and is something that is changing drastically the food system from the consumer side. So I think that's a story of great hope. The response to that has been, and actually Monsanto stole that ad idea. This is how we knew it was good, because they focus group, poll, and test everything. They came out with their own Food is Love series. And then, of course, they spent, and we tracked this funding on the U.S. Right to Know website, usrtk.org. It was $103 million entirely from corporation. Not one single human donated to those campaigns in the 4 states that ran ballot initiatives. So that was Washington, Oregon, Colorado, and California. And since then, we kind of became obsessed. My co-worker in that campaign, Gary Ruskin, was the campaign manager. You know, how are they doing this? How is it such a full court, consistent messaging coming from so many angles? Kind of how is that whole operation working? So we started to research that. That really was the impetus of U.S. Right to Know. And we've since done, we started in 2014, so lots of Freedom of Information Act requests, lots of other kinds of investigations, thousands of documents that have come out of those efforts, as well as lawsuits, because now Monsanto is getting sued by over 1,000 farmers and their families, people suffering from non-Hodgkin's lymphoma over glyphosate exposure. And those lawsuits have, the discovery through that has unearthed many, many more secrets. And so the picture is starting to come clear, kind of the how they're doing it. So I'm going to talk a little bit about some of the messaging and then some of the tactics. And as Ignacio said, it's been 40 years of promises that haven't panned out. And now it's shifting to the public dialogue is shifting to, well, these new technologies, synthetic biology, CRISPR, gene editing sound so benign, like we're just fixing a little mistake that nature made. So this, and it's not GMO. These sorts of messages are really what the industry is focusing on, not health and environmental safety. So we've all heard the messages. GMOs are necessary to feed the world. They will enhance vitamins, resist drought, cure the blind. Pesticides are safe. GMOs are safe, necessary. Anyone who questions them, to even question them, is anti-science and radical. There's also a big attack on the organic industry. And you may have heard some of these messages too. Well, organic eaters are just elitist, nanny, lecturers telling the rest of us what to do. The tyranny of the organic mommy mafia. That's one of the headlines in New York Daily News. I tell about that story in a lot of my presentations because when I looked into who the sources were, it's front groups and professors who work with front groups and professors who wrote reports attacking the organic industry while taking money from the biotech industry and working directly with Monsanto to attack organic and GMO activists while keeping Monsanto's fingerprints hidden. And then it turned out the writer herself also was aligned with one of these front groups. So the how they do it, the bottom line is keeping this system going, an industrialized, chemical-intensive, genetically engineered, corporate-controlled food, farming, and land use system necessitates they have to run massive propaganda campaigns. And that is staggering, the numbers associated with that. I did a report a couple of years ago, and we're now updating it with Friends of the Earth and Anna LePay, called Spinning Food, where we looked at some of the groups, the money they're spending, consistent messaging. We found it was almost $1 billion, actually, over 5 years spent on communications, campaigns, and some of that lobbying on a very pretty narrow set of messages. GMOs are necessary, pesticides are safe, organic is not worth the money, and this, we have to continue. The factory farming system is not that harmful, and we really don't use that many antibiotics. And so the soldiers in that war of misinformation are many. We've got the front groups, over $10 million a year being spent on about 15 front groups, Food and Farming Alliance, the Center for Integrity, Coalition for Safe Food, these sorts of names, Academics Review. That was the one where we had all the emails showing this Academics Review started by a professor at the University of Illinois. They produced a report attacking the organic industry, said 15 times they are independent, completely independent. It's all over their website, all over their report. We have the emails showing this fellow, his name is Bruce Chassie, working directly with Monsanto and their top PR guys to find the money to set up a front group to attack activists and hide the money. So it's pretty clear what's gone on there. That's a very stark example, but there are lots of people involved in this system. Professors who are taking the lead from Monsanto in what they write, what headlines they should use, where it gets published, and then the PR support behind the scenes to push those articles out all over the internet. So the front groups, professors, journalists, some key, well-placed journalists who repeat the industry's messaging very reliably. And of course, they have a great control over what science gets done in the first place due to research dollars that go to universities. So, massive propaganda campaign, staggering in scope, hundreds of millions of dollars, and yet, still, more and more and more people every year, people across all demographics, across this country, around the world, in industrialized countries, want organic food. That demand is increasing. People want to know where their food comes from and how it's produced. And so they're not winning in the marketplace. What they are controlling is the policymakers, the media elite, and the rules that get set for how genetic engineering is used and brought into the world. And so that's where I think Jennifer Doudna's nightmares and time awake at night is really real, because we have to consider those technologies rolling out in a system that is working for profit and not for the common good. And so I don't see how we get past that, but for we have to stay in the game. Consumer activists, those of us who care about food, who know food as a source of healing for the planet and for ourselves. And so thank you to all of you for all of the educating that you do in your own lives about food as healing and the potential for changing our food system to set us on a path to healing.
By the way, you know, Friends of the Earth came out with this brochure that's on a lot of the tables out there. I have a few extra if anybody else wants one, but Stacy was real involved in helping to put this together too. Thank you, Stacy. So our next speaker is Michael Hansen. Michael is the senior scientist at Consumers Union. He's a biologist and ecologist who did his PhD in the techniques of integrated pest management. Consumers Union is an NGO focusing on product testing, investigative journalism, and consumer advocacy, founded in 1936. You know, I almost feel like I grew up with Consumers Union. You know, from everything from doing the fight against, you know, getting seatbelts in automobiles to fighting the tobacco industry, which it's amazing how many things that we're dealing with are reminiscent of that fight against the tobacco industry. But anyway, And in addition to that, Michael has been for, I think, all of the people in NGOs, et cetera, that have been trying to get their handle around the science behind many of these emerging technologies. It's always Michael, who we all go to help us understand that. So he's played a huge role in that. You know, he's also been very involved in the Codex Alimentarius Commission, which is the intergovernmental body within the framework of the Joint Food Standards Program established by the Food and Agriculture Organization of the United Nations and the World Health Organization. So he's been helping, you know, in that battle on the worldwide front as well. So thank you for being here, Michael. Oh, and you've got to tell us the story about the Impossible Burger too, which is, thank you.
Thank you. It's actually an honor to speak here. In addition to what Mark said, I would just like to point out that Consumers Union was a founding member of Consumers International, and that's a global network. We have 220 members in 115 countries. And so in addition to the work at Codex, I've done a lot of work helping consumer and peasant organizations around the world, but particularly in Asia, educating them about this whole issue of genetic engineering. And I'd like to follow up first on some of the things that Ignacio was saying. This really is based on the central dogma. And that's the idea that DNA is the master molecule, right? The DNA causes everything. And so the only thing that you need to do is, once you find the proper gene, then you'll get the trait you. Since then, that the central dogma said DNA is the master molecule. Information flows one way, from DNA through RNA onto the trait, right? We now know that there's actually this feedback system that happens, and information comes from various places. And so the problem with genetic engineering is it really is this myopic focus on thinking that DNA is the answer, and not looking at the context, not looking at the ecology of the situation, whether it's for the organisms themselves individually or their populations. That's why, even though there have been over 15,000 field trials in the US involving 70 different plants, virtually none of that has led to commercial products, because they keep on failing over and over again. They've now come up with this next generation, and the way they push it is this semantic intervention. It isn't just using that term. Even the term gene editing is a semantic intervention, because when you listen to that term, you think, oh, editing. Editing is something that's very precise, right? And this isn't. And in fact, what's interesting is the people that are pushing these new waves, when the first wave of GE came in, they talked about how much more precise it was than conventional breeding, because with conventional breeding, you're mixing thousands of genes or tens of thousands of genes, whereas with GE, we just move one, right? Well, but they couldn't control where they were inserting it, so that led to all this unexpected variability. They kept on denying that would happen, and then 30 years later, what is their argument for the use of gene editing that? It's like, well, this first generation is really not that exact. This new generation, gene editing, is far more precise and accurate. And then I would have reporters come to me and say, talk about how isn't this far more accurate, because with conventional genetic engineering, you can have, since you can't control where you're inserting something, it can cause all these off-target effects, and this is a much more precise technology. And I just sort of laugh when I hear that, because what I would tell these reporters is, you know what? 30 years ago, that was the same argument that they used when genetic engineering was coming in, comparing it to conventional breeding, that it's more precise and more accurate. Some of us were saying back then, no, it's not. There's all these off-target effects because you can't control where things are being inserted. So what do? 30 years later, they admit, yes, there are all these problems, we can't get them to work, so we'll have this more precise thing. And they even use the term editing, because everyone thinks about how precise that is, but what they don't realize is not only does it cut, you can tell it where to cut, but it not only cuts there, that same sequence, it'll cut wherever it sees it, and if it's a similar sequence, it might cut there. So that means you can get all these off-target effects with gene editing as well. And so, for example, you know, CRISPR has been hyped about how exact it is and how it does all these wonderful things. In June this year, there was an article published where they looked at these mice that they edited one gene that was causing blindness. And what they did is they did whole genome sequencing. And they looked at, they used CRISPR to make in 2 different strains of mice, you know, specific changes just in one gene. So what the scientists did is they said, well, let's scan the whole genome. And we'll compare that to other mice and see how many changes have been made. So in addition to the intended change, this group found in one strain of mouse, the single nucleotide variants, these are individual base pair changes. In one strain, it was 1,736. In the other strain, it was 1,696. Oh, and also, in addition to those kind of mutations, you got what are called indels, and that stands for insertions or deletions, right? So in one strain, it was 164, the other it was 128. And furthermore, when they looked at a database of the genomes of 36 strains of mice that are part of this mouse genome project, all these changes that they think might have been made by CRISPR weren't found in any of them. So there's all these off-target effects with CRISPR, and so it's not exact as you think. In fact, just about 2 weeks ago, people probably saw that big story about how for the first time in a human embryo, they made an exact change and they only affected that gene and didn't affect anything else. Well, it now turns out that George Church and others at Harvard have pointed out the serious problems in that study about they really didn't look and they didn't sequence the whole genome. So if you get a deletion that's more than 200 base pairs, it would look like there's no change when, of course, there has been a change. So I think the point is these gene editing technologies, they think they're going to be far more exact, but again, what they're focusing on is that the genes are the only things that are important, not the context, not the whole context of the genome or the population they're in. And before I tell you the Impossible food story, the Impossible burger story, I just want to mention when I was flying out here, I picked up the this week's New Yorker, and there's a wonderful article by Mukherjee, and it's on cancer and how people have focused on the genetics of cancer and finding the genes that cause cancer, and they're starting to realize that that's really a bad focus, because it turns out many people can have those cancerous genes or even cancerous segments, but they don't develop cancer. Why is that? Because cancer is an interaction between genetic change and the environment that it's in, that is the tissues. And all of cancer research has focused on the seed, which is what they call the DNA, right? Without looking at the ecology of the organs and the cell systems they're going into. And some people now are realizing that, wait a minute, actually we need to look at this at the whole system. And when I read that article, I said, this is a perfect analogy for what's happening with these next-gen biotech products. Because again, they think that genetics is everything. That once we know the genes, we completely understand things. But we don't, and very quickly, that human genome project that Ignacio talked about when Craig Venter and all them stood up, what they had done is they'd sequenced the human genome. And what they realized at the time is they thought, then we'll be able to, you know, cure all these diseases. And at the end of the day, they said, wait a minute, there's only 25,000 genes. There's hundreds of thousands of proteins. That means genes can't be the only thing. So very quickly with the Impossible Burger, what I want to talk about that is this plant-based burger, but yet it bleeds and looks like a regular hamburger, and that's because of the presence of this heme or hemoglobin. And I should point out that what they've done is, even though this soy leg hemoglobin that they're putting into this burger, that's never been in the human food supply before. That soy leg hemoglobin is only found in the root nodules of the soybeans, right? So that means it's never been in the human food supply. Now they want to add it into a food and not do any safety testing. And that's completely crazy, because what's interesting is actually there are 3 different hemoglobins that occur in soybeans. There's hemoglobin, truncated hemoglobin, and leg hemoglobin. The first 2 are found in the above ground portions of the plant. Why didn't they use those? Because at least you could have some argument that maybe those had been in the food supply before. This hasn't. And in fact, when they submitted this GRAS petition, this generally recognized as safe notification to the FDA, they didn't really have any data. They literally, all they did was say, well, soy leg hemoglobin, that's that's similar to all these other hemoglobins when you look at its 3-dimensional structure. That's also similar to molecules that bind oxygen and heme, which is iron, and such as myoglobin. And we've been eating myoglobin for thousands of years, so this is just the same thing. No, it's not. This is a new food additive. And it did not go through any safety assessment. The FDA properly, in their case, they pointed this out to the company. And it turns out that thing that is over 1% of the weight of the Impossible Burger, it's not all just this soy leg hemoglobin. In fact, only 72% of their product is the soy leg hemoglobin. What's the other 27%? Well, that's 46 other proteins that come from the yeast that was engineered from the vat. Again, all those materials have never been in the food supply, and as the FDA told the company, the data that you've submitted do not meet general recognition of safety. You would have to demonstrate that not only is the soy leg hemoglobin safe, but the other 46 proteins are. And I should point out, the company submitted this GRAS notification in 2014. A year later, in 2015, they withdrew it. The reason they withdrew it is they knew that the FDA wasn't going to say anything positive. There was a FOIA earlier this year that was done by Friends of the Earth and ETC Group, and all this came out about basically how bad their lack of data was. And what they did is, here the FDA has told them, you have not demonstrated this as safe, and they just ignored that. And in the first place the Impossible Burger was sold was at Momofuku in New York City. Now it's in all these various chains. They're ramping up. They claim they're going to be in 1,000 fast food chains by the end of the year. They announced yesterday this new facility in Oakland, and it's based on, they spin this tale about how wonderful this is, but there's no data to suggest it's safe. And as the FDA said, there's evidence to suggest that there could be problems here. And I'd just like to say one more thing before I go, because I've had calls from reporters and others saying that they'd heard that maybe Big Meat put pressure on the FDA to go after this company. And my response to that is, I don't know whether that's happening. All the FDA was doing their job, because when you look at the data they submitted, it was horrible. And so the fact that anyone who says that this product should be fine, it contains an ingredient that's never been in the food supply and has not gone through any basic safety assessment. That should not be acceptable, whether the product is engineered or not. Thank you.
Thanks, Michael. And by the way, you can buy those burgers. They're for sale. I don't know where you get them, but they're if you want to taste one. So.
There's actually, Dana could tell us that there's 5 or 6 chains here in the Bay Area that sell them.
Yeah, which is shocking. So thank you. You know, you can tell that, you know, we could go on for hours in this conversation, and it is amazing. You know, we only really touched on some of the technologies that are, you know, like I wish we had talked a little bit about gene drives, which you just read about them, and it's like you might as well be reading science fiction. It's kind of so scary, the implications. But thank you. Read your pamphlets. That'll give you a little bit more background.